Hello everyone, in this video I'm going to show you how to design an oscillator based on a common collector amplifier. To start with, let's take a look in one of the circuits one of the common collector amplifier that we have designed in one video lectures. So this is the one. We have a biasing circuit here and we construct the circuits we short circuit the collector to the AC ground. So we are going to design an oscillator later out of this one. First of all, we need to know that in oscillator is not the same as amplifier. In amplifier, you might have R1 and R2 here to maintain a stable bias circuits. But in oscillator design, you are going to use the output to feed the signal back to the input. Input is here, output is here. We are going to build a tank circuit to feed into here. But you have a resistor here. So it's a kind of obstacle. It will produce damping to the tank circuit, to the input. So what we can do here is, first, we are going to rebias the circuit. We don't use this resistor. We delete this. And we are going to bias it again. And we need to make sure the current here is enough. So we make it say 400. Yeah, because this kind of biasing circuit need a very big resistance here. And we are going to simulate the DC operating point and make sure we have enough current to drive this transistor. So we have 3 milliamp. I think it's good enough. It may be better to make it lower. So from what I can get here is about 1.3 milliamp. So I believe this biasing point is very optimized. Okay, so the DC biasing is done. Now we don't need output and input there. So we delete it. We delete this as well. And we are going to design a tank circuit. And the tank circuit has 2 capacitors. For the time being, we make it equal. We make it 100 peak. So the input will be fed to the middle of this series capacitor. And then we build a inductor here. So this is a very basic colpitts oscillator. So here maybe 110 nano. So equivalently, let's check the frequency. 1 square root of 10 nano and then times 50 pico. And 2 pi. And let's check. So I should get about quite large, right? 225 megahertz. So let's do this for this circuit. I think it's a good one. So what you need to do here is you cannot just connect it direct to here. The reason is in DC the inductor is short circuit. So when you do that, then there will be low DC current delivered to the transistor. So you need a huge capacitance here. A capacitance, say 1 micro. Yeah, this is big enough. So this is the kind of circuit that you might like. And then I can be, and then we need to do this, right? Starting point, you will start storing data. And the maximum timestamp, I suggest 10 nano. You have to specify this, otherwise it won't converge. So I hope we will get something. So indeed, we managed to make it oscillate, even with this very, very poor transistor. And the oscillation amplitude is not very good. It just oscillates. And let's check the frequency. The good thing is the signal is amplifying. Yeah, let's check the frequency. So from what I can get here, I got 200 megahertz. So it's very close to what I have simulated. So I think the oscillator is successful. Now the problem is the oscillation amplitude is not high. It just is even less than 1 watt. So my suggestion here is there are many things you can do to improve the circuit. First, you can replace this transistor. One of the reasons why it doesn't work well is we are operating at a frequency beyond the bandwidth, the available bandwidth of this transistor. So we need to pick another better transistor that operates at a much higher frequency. Here is my suggestion. One of the transistors that I have tested before is BC 546. BC 546. So this is the one. Let's check whether there's any. Normally you need to look for the transistor with lowest possible CJC. Let's check it. So CJE is 140 micro, very big. But let's check CJC first. CJC is so 12 pico, not very impressive, but it might work. Might work. Sometimes it depends on some other thing as well. 12 pico. Now we have one here, very quiet, very low. We have 3.7 pico for CJC. So perhaps this is a good one. Let's check whether there's any better one. Most of the transistor here has very low CJC. Okay, I will pick this one. I will pick this one. Okay, so let's simulate this again. So not too bad. We have at least 2 volts amplitude. At least 2 volts. So the circuit was successful. And this is the way how we design an oscillator. Uh, so this is the oscillator specific to common collector amplifier. Okay, so if you have further question about this circuit, please let me know by entering your questions in the comment section. For my part, I have already given you this example. Let's check it again. I got 200 megahertz. The simulator value is 200 and the calculator value is 225 megahertz. So it's consistent. So please leave your question to the comment section if you have any question. For my part, I have done my job. Thank you.